Okay, this is the second part of the notes that we're working with for Honors Math 3. This is example 4, and your turn to go along with that. These problems they can be tricky, but I kind of like them because in the end, they really come out to be, a lot of things cancel out, and so it tends to work out. One of the things that I will not recommend you do is try to operate with these i's by hand. Remember that the expressions that involve I always have a plus and minus that expression with the I. So if it's 1 minus 2i, it's going to also have a 1 plus 2i. Gotta fix this zoom. So 1 plus 2i would be considered the conjugate. So they always come in pairs. So in order to work through these are already our solutions. We're not going to have any real zeros here. So we're simply going to write synthetic division. And I'll start with the 1 minus 2i. Again, I'm not changing any signs. I'm going to write my coefficients. So this is going to be 4. And notice that we're missing a third power. So that's going to be 4, 0, 17, 14, and 65. Now, we got to operate with these. So let's bring down the 4. Try to leave yourself plenty of space between these numbers so we could write our two terms. We're going to do 4 times 1 minus 2i. Well, that's just distributing a 4, so 4 times 1 is 4, minus 4 times 2i is 8i. And again, we add down, so 0 plus that is going to be 4 minus 8i. Now this lesson, I don't get into the how for how you operate with the i's. This is where you need to just use your graphing calculator and get the solutions. So again, make sure your mode is set to a plus bi. And all I simply want you to do is do 4 parentheses 4 minus 8i. I is the button down here. And times that by parentheses 1 minus 2i. Okay, that ends up being another expression with two terms, so the real part and the I part. So we're going to write that underneath the 17, negative 12 minus 69. And then we're going to add down. So the 17 and the negative 12 will add to positive 5. The negative 16i is going to stay the same. You can double check that. That's just going to be 5 minus 16i. So I'm going to write that here. Again, we're going to take that and multiply by the 1 minus 2i. So I can actually just hit the times, and it'll take my previous answer. And in parentheses, I can do 1 minus 2i. Close that up and press enter. You get negative 7 minus 26i. Add the 14. Negative 13 minus 26i. Times by 1 minus 2i. Negative 65. And look at that. Those cancel out and give you a remainder of 0. So we have our way of knowing if we did it right, because if we got something else, then something went wrong over here. So just use your calculator to get those values. Again, do it with the conjugate. So now do the 1 plus 2i. Remember, i's come in pairs. So bring down the 4. Oops, that's supposed to be a plus. Of course, that's 4 plus 8i, and you should probably know that that just distributes 4 and 2i is 8i. So, but the nice thing about this is you'll notice the i's will cancel, so that's just going to give you 4 and 4, which is 8. And if you do 8 times 1 plus 2i, well, that's 8 plus 16i. Of course, you can do 8 times 1 plus 2i if you so wish. And opposite signs cancel out. 8 and 5 is 13. And do the same thing with 13 times 1 plus 2i. So it's going to be positive 13 plus 26i. Those cancel out, both of them, so that means your remainder is 0. And again, that's what we're looking for. So finally, we have our quadratic expression, 4x squared plus 8x plus 13. And we set that equal to 0. I would use quadratic formula for this, so I have the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And let's double check underneath the square root sign what we get. So negative 144. Well, 144 can actually be square rooted. So the square root of negative 144 is going to be 12i. So that will become negative 8 plus or minus 12i divided by 8. Now in this problem, I would separate these fractions out. So that's really negative 8 over 8, which is negative 1, and 12 over 8i. And if you can't reduce that, you can use your calculator if you need to. 12 over 8, well, that's 1.5. And if you convert that to a fraction, you get 3 over 2. So this is going to be negative 1 plus or minus 3/2 I. So the other solution, so first of all, it says what are all the solutions? The only one that was actually given to us was 1 minus 2i. So the other ones would be 1 plus 2i and negative 1 plus or minus 3/2 I. So I'm just going to write all the solutions out. And they're all complex. So you would not see any of these cross the graph, and that's kind of the point of these. Okay, pause the video, try that last problem, and I'll have the solutions displayed for you. Okay, so having worked through this, they give you the 1 minus 6i as your solution. I went ahead and wrote out my synthetic division. I didn't have any zeros to put it as a placeholder, so I just brought down my numbers and used my calculator and multiplied, added down, use your calculator to multiply, make sure you use parentheses around them, add down and kind of watch the work. You get a remainder of 0. Then use the conjugate. Remember that if it's 1 minus 6i, the conjugate would be 1 plus 6i. And do it again. You'll notice that all the i's go away, and you're left with your quadratic, which is going to have to be used in the quadratic formula in this problem. So that will be opposite of 4 plus or minus the square root, 4 squared minus 4 times a, which is 1, times c, which is 29, all over 2a, 2 times 1. And if you simplify that, well, you get 4 plus or minus, that ends up being negative 100, which you can square root 100. So the square root of negative 100 is 10i, and 2 times 1 is 2. Turns out those are both divisible by 2, so 2 plus or minus 5i. So my 4 solutions would be 1 plus or minus 6i, and 2 plus or minus 5i. I hope that makes sense, and make sure that you complete the Unit 3 Day 4 assignment. I'll check that tomorrow in class.